Hello guys, good evening everyone. Welcome to this session and welcome once again to the GATE and ESC 2024 Fundamental series, and we are learning signals and systems in this fundamental series. And yes guys, today is the time to discuss discrete time periodic and aperiodic signals. In the last class, that is the yesterday, also we discussed about periodic signals and aperiodic signals, but we were more specific to continuous time periodic and aperiodic signals. But as I told you, there are certain differences between the periodicity of a continuous time signal and a discrete time signal, and that is why discrete time session will be separately conducted, and that is what, this is the separate session on the discrete time periodic and aperiodic signals. Very good evening everyone. Once again, welcome. Good evening Ravi Chandran. So let us get proceeded. This is the introduction already, you know. And yes guys, as I've been telling you, from this Sunday, that is 2nd April, we are bringing you yet another fresh new series. That is the Sunday special. Sunday special Learn with Fun. The Sunday special Learn with Fun. Yes, to make you explain GATE concepts through practicals, through experiments, so that you are able to relate what you study, so that you are able to arouse some interest in your preparation. And if you want to know what the sessions are going to be, this is first example where me and Ashu Hangra sir have performed an experiment, and we are going to explain you the skin effect. We are going to explain the skin effect with the help of that experiment on this Sunday. Join us live on this Sunday. So subscribe to the channel if you want to have this all learning even with the fun. Okay. So guys, now DT periodic signals. Now we have already defined what periodic signals are. Let us not repeat that fundamentals, because yesterday we clearly defined. Okay, so periodicity, a signal is repeating after every finite duration of time, and here I am taking a discrete time signal. Okay, and as you are able to see, after a specific time n, which could be even any value. So here it looks like this is 1, this is 2, this is 3, then 4 and 5 and 6 and etc. Okay, let me mention some values also. Let's say this is 1, this is 2. Okay, so what is this? This is one cycle, this is one block, and you are able to see the signal that is at origin. The same part repeats at n equal to 3, and hence it repeats only. Now what is the pattern? This is the pattern 2, 1, 1. Again, this is the pattern 2, 1, 1. Okay, so the pattern in one cycle, which is 2, 1, 1, is repeated continuously after time period equal to 3. Okay, so what is that minimum duration? See, if there is a repetition after 3, there is a repetition after 6 also. There will be a repetition after 9. We have learned all these things. But the minimum duration of time after which repetition occurs is known as the fundamental period. So if I want to describe the DT periodic signals, I will be simply writing a discrete time signal is periodic if it satisfies x of n is equal to x of n plus n. If it satisfies x of n is equal to x of n plus n. But not only this, as I have been mentioning you, that if x of n is equal to x of n plus n, and not only plus n, minus, it will repeat to the right, it will repeat even on the left also if you come n units back. But not only it repeats after n, it repeats after 2n, repeats after 3n, it repeats after every time capital N. So it could be x of n plus minus 2n, x of n plus minus 3n as well, or in general that can be written as x of n plus minus kn, where k can be any integer. K can be any integer, right? That is what is the basic definition of periodicity. We learned yesterday also in the continuous time class. Okay, this is yet another example of DT periodic signal, a discrete time periodic signal. Okay, where if you consider in one cycle there is a ramp waveform. Okay, and then henceforward it repeats. This one is starting from minus 15, this one starts from minus 5. Okay, next one is located at 5. Okay, because of this minus it is displayed. Actually this is minus 5. Okay, then this is 5, right? Then that is 15. So minus 5 should be seen here. Actually this is what is minus 5. This point is minus 15. Okay, and I can clearly see that this particular signal is again periodic, having what period? Okay, let us measure from these 2 points, the top 2 type. You can take any 2 points to measure the repetition, and it is minus 5 to plus 5, and that is equal to 10 units. So the time period is equal to 10 units. Okay, you can have a sine omega n or a cos omega n, but very important point. if I go back to the continuous time domain, as I clearly explained you yesterday, that in continuous time domain, dear, a sine omega t or a cos omega t, they are always periodic. Clear? Why? I have explained you, they are always periodic and having the period equal to 2 pi by omega. Good evening, Prasad. But if I want to discuss about the dt domain, that is the discrete time domain, and then if I consider the signal a sine of omega n, where omega is the frequency, again the fundamental frequency, or it could be even a cos omega n, whether this signal is periodic, even in the discrete time domain, whether it is periodic. Okay, my answer is maybe. It is not always periodic. There is a condition. Good evening, dreamer. What is that condition? Okay, chalo. So if I take xn is equal to a sine omega n. Okay, and if I define x of n plus n, so that will become a sine omega, n is replaced by n plus n, so this becomes a sine of the omega n plus omega n, capital omega n. Now, if I want this to be equal to xn, periodicity yahi bolta hai na, x of n plus n should be equal to xn. Okay, so I am able to feel that a sine omega n plus omega n is equal to a sine omega n. And that is only possible, okay, if you talk in terms of trigonometry, the sine theta is periodic having the period of 2 pi. The value of sine theta will repeat after 360 degree, after 2 pi radian. So definitely this should be 2 pi. So sir, once again result to wahi aa raha hai, omega n is equal to 2 pi. That means the period is 2 pi by omega. So sir, same hi to result aa raha hai. What is the difference? But the story continues. Now you will understand with one example why, although I am getting the similar formula as we get for continuous time domain, but what is the fundamental problem here? Isko dekh lete ek baar. Have a look into an example. Chalo, have a look into an example, dear. Let me explain you with an example. Just a moment. Dekho. Suppose, dear, if I take an example, x of n is equal to sine n, right? X of n is equal to sine 2n, for example. Okay, then as per the sine omega n theory, it should be periodic. And what is the period? N is equal to 2 pi by omega as per the formula. Okay, so that is 2 pi by 2 and that is equal to pi. Abhi hold karte, I will tell you. Look at that, the time period of the signal is coming to be pi. Think. Okay, by the time I write, you keep on thinking. Now, let me take another example where I take xn is equal to sine of pi n, right? Then you can feel that its time period is 2 pi upon pi, which is equal to 2. And let me, dear, take another example where I take xn is equal to sine, ye kitna tha? Pi n. Let me take 4 pi n, and then you might feel that the time period is 2 pi upon 4 pi, which turns out to be 1 by 2. Now, dear, understand the problem. This is only the calculation. The point is, here you are finding the period of discrete time periodic signal. And period is the value of time, minimum duration of time after which repetition occurs. Okay. If there is a value of the signal at origin, the same value repeats at n. That is the time period n, I can say. Okay. But since you are in discrete time domain, what is that important thing you know about discrete time signals is that discrete time signals are only defined for integral values of time. the discrete time signals are only defined for integral values of time. So whatever is this time period, whatever is the time period, it must be integer, otherwise it is not a valid time period, because DT signals are not defined. DT signals are not defined for non-integral values of time. And that is the condition coming up here, right? What is the first value I have obtained? N is equal to pi, which is definitely not an integer. Case number 3, N is equal to 1 by 2, which is again not an integer. But still there is a difference between case 1 and 3. Case 2 पे आ जाते हैं, simple one, N is equal to 2, which is a integer. So in this case, let me actually call it as x2n, x1n and x3n. Let me call this as n3, n2, n1. Okay, right. So n1 is equal to pi, n2 is equal to 2 and n3 is equal to half. N2 is directly an integer. So very clearly, my conclusion is ready for you that x2n is 100% periodic. But x1n, although it is a sinusoidal signal, but it is aperiodic. But if I talk about x3n, it is still periodic. Sir, what sort of joke is this? How it can be periodic? Its period is non-integer. So how it is periodic? We know that the period for discrete time signal can only be integer. Discrete time signal is defined only for integral values of time. So dear, understand the point here is, I told you one thing, if a signal repeats after capital N, it will repeat after 2n, it will repeat after 3n, it will repeat after 4n, it will repeat after 5n, it will repeat after 100n, 200n, it will repeat after every n. It will repeat after kn, I can say. So now I can say that logic here is, if the time period turned out to be half, which is not an integer, but mathematically I can say x of n, is equal to x of n plus half. But since it repeats after half, it should repeat after another half. And that is why it will also become x of n plus 1. Right? It will repeat after every half. So it is also equal to x of n plus 1. That means x of n is equal to x of n plus 1 is equal to x of n plus 1, and here this is what is your final time period, which is equal to 1, right? Okay, this is not the time period. N3 is not the time period because it is not an integer, so it cannot be the time period, but still the signal is periodic. Because now we understand the reason. It is not integer, but it is the ratio of two integers. Numerator upon denominator, both are integers. And because you have numerator by denominator, if you take a 1 by 2 into 2, you get a integral time period. Suppose it was 1 by 3. You can take 1 by 3 into 3. It repeats after 1 by 3, 2 by 3 and 1. So 1 by 3 into 3 you can take, then you get the integral value of time period. Okay, so whenever you have ratio of integers, which is a rational number, okay, it is not an integer, but this is still a rational number. Okay, then the signal is periodic. But here, the first case, you got the period which is not an integer, and also at the same time it is not a rational number. Or I can say that it is irrational. At least it has to be rational. But here it is irrational. Oh, just a second, guys. There is some problem with the connection here. Just a moment. Just hold on, guys. Hi, guys. Are we now connected? Let me just check that again. Yeah, I think that seems fine now. Okay, correct. Yes, guys. So I don't know why the smart board suddenly got switched off. Maybe some issue happened. Okay, we'll figure that later. But let us continue the class now. Let us continue the class. Okay, fine now. Okay, so that is what. What is the final condition that actually came up is कि for the signal to be periodic, its time period either should be directly an integer, well and good. Even though it is not integer, but if it is a rational number, if it is a rational number, ratio of two integers, then there is a possibility that you can multiply it by the integer, suppose 2, so that 1 by 2 into 2 becomes an integer. Final period has to be an integer. But if it is irrational, at any cost, you cannot make it as a integral by multiplying by any number. Okay, so final conditions, that is what we all discussed. The final condition, go back. What happened to this now? Yeah, the final condition, as we have already discussed, that a discrete time signal A sin omega n or A cos omega n is periodic if 2 pi by omega. So don't directly call 2 pi by omega as time period, because sometimes 2 pi by omega may be rational but not an integer. So this is not the time period. Okay, so I will not say my time period is 2 pi by omega, but first I will calculate 2 pi by omega, and if that is a rational number, then the signal will be periodic. This is the test of periodicity. Then what is the period? If it is directly an integer, then that is the period. But if it is a non-integer like 1 by 2, multiply by the denominator. Simple bole na. Formally we write it like this. The period is 2 pi k by n, 2 pi by omega into k. This is like 2 pi by omega, which is rational, okay, multiplied by some number k, where k is the smallest integer, so that the final time period becomes an integer. एक और example देखेंगे, sorry. Let me first take the one more example here. Okay, suppose dear, if I take the case of x of n is equal to 2 cos 3 pi n. Is this periodic, and if yes, what is the period? So first of all, I would calculate 2 pi by omega, and that is equal to 2 pi by 3 pi. Pi to pi cancel, so it is 2 by 3, which is the ratio of two integers, and ratio of two integers, yes, it is a rational number. Yes, this one is rational. And if this is rational, it has to be periodic. What is the period? Now, simply think now, what to multiply? 2 by 3. You have to make the integer. So, you have to cancel the denominator, right? So, what should be the final time period? 2 by 3 multiplied by 3. Now, you can multiply by 6 also. Sir, multiply by 6 here, then also you get integer. But we all know time period means the smallest value of time for which repetition occurs. So, multiply by 3, that will be equal to 2, and this is the period. This is the period of the signal. So period cannot be 2 by 3. Period will be 2. I hope you have got the fundamental now. So in discrete time domain, A sin omega n or A cos omega n are not always periodic. हमेशा periodic नहीं होते हैं. They have a condition. But what if I add periodic signals? In the continuous time domain, addition of periodic signals was tested by a ratio test. Remember? T1 upon T2 should be a rational number. But here, if I take xn is equal to, एकदम quickly बता देता हूं मैं, if you have followed the yesterday's class. Okay, suppose x1 and x2 are both periodic with the periods n1 and n2. This is having the period n1, this is having the period n2. Then as per the yesterday's derivation, I'm not repeating it, you can go to the yesterday's lecture. But as per the yesterday's lecture, for the addition or subtraction of two signals to be periodic. Okay. This I taught you yesterday. Okay. The n1 upon n2, the ratio of the time periods should be a rational number. So we had a ratio test. You can refer to the yesterday's class available on the channel. Okay. Acha. But here the results are simplified. You can feel that there is one thing which we have been discussing, that in discrete time domain, the time period should always be an integer. So n1 and n2 are automatically integer. Here n1 and n2 are already integer. The time period are integers only. So when you divide them, you are already taking ratio of integers. So 100% it will satisfy the ratio test. If you want, apply the ratio test. But I am telling you 100% it will satisfy the ratio test. 100% it will satisfy the ratio test. Right. So n1 by n2 is rational always. Is rational always. Clear? n1 by n2 is always rational. And if it is rational, it can be expressed as ratio of two integers. It can be expressed as ratio of two integers, right? So it should be of the form p by q. So what is the final period? ये भी तो पता करना है. चलो, it will always be periodic, but what is the final period? First method, the final period. As I told you, first method is cross multiply. So cross multiply q here, so that will become q times n1. Or cross multiply p with n2, that can also be the value. Both will give the same answer. Or second method is n is equal to, dear, what is the second method? LCM. Why we take LCM? I explained you yesterday. So today let us focus on what are the differences in the question in the approach of DT and CT. Okay, but whatever derived and explained yesterday, okay, usko hum repeat nahi karte. Okay, so it can also be written as LCM of n1 and n2 as we discussed yesterday. Clear? So now understand the difference between CT and DT. Okay, अगर मैं CT की बात करूं and अगर मैं DT की बात करूं, let me make a table. Two important results. Number one result. A sin omega t, sinusoids, or A cos omega t, right? Always periodic. Period is simply 2 pi by omega. No conditions apply. But अगर dt में बात करें, so A sin omega n or A cos omega n, basically discrete sinusoids. Okay, they are not always periodic. They are periodic if the 2 pi by omega, if the calculation 2 pi by omega is turning out to be rational. Okay, then what is the final period? Okay, the final period n is given by 2 pi by omega into k, where k, I am not repeating, it is already written. K is the integer, smallest integer, which will make n equal to integer. N has to be integer, right? N has to be a integer. Question भी solve करके बता दिया है मैंने. Okay. Second point. What is the second point? Okay. In the continuous domain, if I add or subtract two periodic signals, x1t plus minus x2t, right? xt is periodic, not always. xt is periodic if, यहां पे addition पे condition है, if the t1 by t2, if the ratio of time periods is a rational number. So we have a ratio test. Okay. But here xn, which is equal to x1n plus or minus x2n, is always periodic. Here there is no condition required. Here this is always periodic. Clear? Is always periodic. Then what is the final period? That is the same, right? Final period, cross multiply and the same rules, or LCM. Two methods are there to take the final period: cross multiply or LCM method. Okay. So this is already we have briefed the detailed theory in the previous slide, even in the yesterday's class. But this is the comparison between the results of CT and DT signal. आगे क्या है? Okay, sir. Simple question. Here it is. Here is simple question. First, You have to check whether it is periodic or not. If periodic, then calculate the period. Okay, so sir, what is the 2 pi by omega? First step is check 2 pi by omega. Sir, omega is 2 pi by 3. So 2 pi cancel, 3 will go above. This is 3 by 1. This is rational. Okay, so yes, it is periodic. Acha, not only it is rational as well as integer. Right, and I told you when 2 pi by omega is directly an integer, then that is the period itself. Then that is the period. So period is directly 3. It is already integer, na? Why do you have to work hard to make it integer? It is already integer. So next question. Sine 5 pi n by 3. Sine 5 pi n by 3. So again my first calculation will be 2 pi by omega. Omega is 5 pi by 3. Pi to pi, at least pi is cancelled. Your headache is gone. It will not be irrational. Okay, pi cancel, 3 going above. 3 2s are 6 divided by 5. It is 6 by 5. It is not integer. But it is still rational. At least, thank God, it is rational. So signal will be periodic. Signal will be periodic. Okay, so what is the final period? Logically, socho. Okay, it is ratio of two integers, multiply by the denominator number, so that denominator will cancel and you will get the integer. So simply the time period is 6 by 5 multiplied by k, 6 by 5 multiplied by any integer, so that resultant is integer. And what is that? Denominator के बराबर रखोगे ना, so that you get cancellation. So time period is 6. Okay, the signal is periodic. But please don't say that the period is 6 by 5. Okay, that is wrong. 1.2. It cannot be the period of discrete time signal. ठीक है जी? चलो अगला बढ़ते. Sir, what is sine 2n? Okay, here 2 pi by, I think already I have solved this question. 2 pi by omega is 2 pi by 2. 2 and 2 cancelled, but pi is left. Pi is irrational. So 2 pi by omega is irrational, and given signal is aperiodic. And if a signal is aperiodic, then there is no period. Right? Yes, smart engineer, many regular average students are doing it even in the preparation time of 6 to 8 months. You still have 10 months. You can definitely excel much more. Start now and don't think here and there. Just be confident about yourself. Be dedicated throughout your preparation journey. That's it, smart engineer. Okay. Now see, there's a simple question, gate 1 mark. Simple question, just for reference I have taken this question. Sine pi square n. Sine pi square n. Sir, what is 2 pi by omega? Here, sine pi square n, if you compare with sine omega n, so omega actually is pi square, and when you take omega as pi square, only 1 pi is cancelled, but you are left with 2 pi by omega, 2 upon pi, and whenever there is pi, it will make the quantity irrational, because pi is an irrational number. Okay, so what is the given answer? The signal itself is not periodic. The signal itself is not periodic, because 2 pi by omega is irrational. Because 2 pi by omega is irrational. ठीक है? So next question. Cos pi n by 9, sin pi n by 7 plus half. Okay. Individually if I take, देखो problem क्या है? Individually first you have to take whether it is periodic or not. Because if one of them is aperiodic, then the resultant will be aperiodic. We are talking about summation of periodic signals. So पहले both should be periodic. Okay. And cos pi n by 9. Okay. What is the 2 pi by omega? What is the 2 pi by omega? Omega is pi by n. Pi to pi cancelled. 9 goes above. This is 18. Okay. This is 18. So this is a rational number as well as integer. So what is the time period? I told you na, if 2 pi by omega is directly integer, then that is itself the time period. You don't have to do any extra effort. Okay. Next for you is sine pi n by 7 plus half. But any initial phase doesn't affect the period. Yesterday I explained you. Focus only on the frequency. Okay. Right. So what is 2 pi by omega? That is 2 pi upon pi by 7. So 2 7s are 14. This is again rational as well as integer. And because it is integer, my answer is same. Now, whenever two discrete time signals are added, the result is always periodic. The result is always periodic. Conclusions, we have learned the derivation also. The result is always periodic. Okay, but what is the period? What is that period? Okay, so So I told you ना, क्रॉस मल्टीप्लाई कर लेंगे. What is n1 by n2? 18 by 14. But express as the simplest ratio. 2 से cancel किया. तो simplest ratio, because you have to get the fundamental period, smallest value of time. So express as the simplest ratio, it becomes 9 by 7. So what is the final time period? Final time period, cross multiply any side, that will become 7n1 or 9n2. Both will give the same answer. तो 7 into n1. n1 कितना है? 18. n1 कितना है? 18. So this is equal to how much? 126. 126. So it is periodic with the period 126. It is periodic. Option number A is correct. It is periodic with the period equal to 126. Or you can directly take the LCM of 18, 14. That will also be 126. Clear hai ji? Right. So 126A is the correct answer. A is the correct answer. ठीक है. So let me add upon one more question here. Okay. So addition or subtraction, both will follow the same result. Are they individually periodic? Are they individually periodic? So if I do the 2 pi by omega for the first one, it becomes 2 pi upon 4 pi by 5. So ये हो गया pi cancel, 2 by 4 half, 5 divided by 2. Yes, it is rational at least. Yes, this is rational. Okay, right. But it is not integer. It is rational but not integer. So what is the time period? First time period. It cannot be 5 by 2, but I told you to multiply by an integer which will convert this also an integer. So multiply by 2. Multiply by denominator, yaar. Denominator cancel ho jayega. Okay, you will only get numerator which is an integer. So 5 by 2 into 2, the time period will be 5. Okay, so this is periodic with the period 5. Second wala aa jate, right? What is the 2 pi by omega for the second one? For the second one, it is simply 2 pi upon 3 pi, that is 2 by 3. Okay, that is 2 by 3. Okay, sir, it is rational. So the second signal is also periodic, but the period cannot be 2 by 3. The period cannot be 2 by 3. So what is the period? 2 by 3 multiplied by the denominator, that is 3, and the period is 2. And the period is 2. Okay. And the period is 2. Right. So now, dear, n1 upon n2 is equal to 5 by 2. So what is the final time period? Cross multiply, you get 2n1. Cross multiply, you get 2n1. Right, 2n1 will be equal to 10. 2 into 5 equal to 10, or 5n2, both are equal. Or LCM of 2 and 5, that is 10. Okay, so this is periodic having the period 10. So again I repeat, in DT domain, in the discrete time domain, whenever you add two periodic signal, result is always periodic. Same doesn't happen in continuous time. But in DT, if both are periodic provided, then the addition or subtraction of them is always periodic. Ratio test always satisfies here. Now next, important question, interesting question. I gave you the question related to it in the continuous time yesterday as homework. Sine of n square. Sine of n square. Sine of n square. Whether it is periodic or not. Sine omega n you know, but argument, time argument is squared. Sine of n square. It is not sine 2n or sine 5n. Sine of n square. Okay. But I can assume, okay, what is the approach of this? See, xt nahi hai, sorry, this is xn. This part is xn. I can assume that if xn is periodic, dhyan dena. If xn is periodic, okay, then it should satisfy x of n plus n equal to xn. It should satisfy, na? This is the property, fundamental property of a periodic signal. It should repeat after every time that is given by capital N. Okay. So let us assume xn is periodic. If it will satisfy, yes, it will be periodic. If it doesn't satisfy, then we have the option number D also. Okay. Now, let's say n is equal to 1. What is the first option? The best way to approach this question is just tally the option once. Let's say it is periodic with period 1. Let's say it is periodic with period 1. तो रख के देखते हैं. Right. So x of n plus 1 should be equal to xn. ठीक है, यह हम दोनों अलग से निकालेंगे. What is x of n plus 1? Right. xn is sin n square. So x of n plus 1 will be sin of n की जगह n plus 1. Sin of n plus 1 square. This is equal to sin of n square plus 1 plus 2n. Right. Sin of n square plus 1 plus 2n. Right. Now, x of n plus 1, is it equal to xn? Sir, what is xn? यहाँ पे है sin of n square. What is there on the left hand side? Sin of n square plus 1 plus 2n. Sin of n square plus 1 plus 2n. Right. Think about this. Think about this. Okay. Sin of n square. Okay. Sorry, ये 2 pi क्यों लिख दिया? This is 1 plus 2n. Okay. Then next will be n. I think, no. There's a typo error with the question, I believe. Just have to check it up once. I'll just check it up once. Just a moment, dear. Correct, yeah. ये sin n square नहीं होगा. Correct. No, this is not periodic. Of course, this is aperiodic. So I'll bring you a new question. I actually wanted to bring something else, but this is okay. I'll modify this. इसको भी modify कर लेंगे. Okay. So is sin of n square plus 1 plus 2n is equal to sin of n square? That is only possible. That is only possible if 1 plus 2n is equal to 2 pi, but that is wrong now. 1 plus 2n. N is what? In discrete time domain, n is an integer. N is an integer. So 1 plus integer can never be equal to pi. Can never be equal to pi or 2 pi. This is wrong. Right? Similarly, x of n plus 2. Next period क्या given है? 2. Okay. Will not be equal to xn. Okay. X of n plus 4 will not be equal to xn. Why? भाई लॉजिक तो यही आएगा ना. What will be n plus 2 whole square? N square plus 4 plus 4n. 4 plus 4n. 4 plus 4n can be equal to 2 pi. Not possible na. Not possible. Not possible. So this is not correct. This is not correct. Okay. So this is not periodic. This is aperiodic. Similarly, the question I gave you yesterday as the homework, उसकी बात भी करता हूं. The question I gave you yesterday as homework, by the same logic, if you solve, again it is not periodic. Again it is not periodic. Again it is not periodic. Okay. Now let me give you a different question. एक दूसरा question बनाते हैं यहाँ पे. Suppose if the question is x of n is equal to sine of, this was n square, sine of pi by 2 n square या pi n square etc. Okay, so sine pi by 2 n square. Sine pi by 2 n square. Okay. And assume all the 4 options as the previous question. Okay. So here, okay. Again, let us assume x of n plus n equal to xn. Assume. If this is true, then it will be periodic. Okay. Now, case number 1. Take n is equal to 1. Okay. Try with the time period equal to 1. So, what is x of n plus 1? X of n plus 1 will be sine of pi by 2 n plus 1 ka square. This will be equal to sine of pi by 2 n square plus 1 plus 2n. And this will be further equal to sine of pi by 2 n square plus pi by 2. Open करेंगे ना bracket को, plus pi n. Plus pi n. Now what do you want? You want x of n plus 1 equal to xn. हो पाएगा क्या? X of n plus 1 equal to xn. X of n plus 1 equal to xn. Will this be possible? x of n plus 1 equal to xn. So that is only possible if I write down sine pi by 2 n square plus pi by 2 plus pi n equal to xn, that is sine of pi by 2 n square. अब देखिए dear, this is again possible if pi by 2 plus pi n is equal to 2 pi. Yeah, any multiple of 2 pi. Can this be possible? This is only possible, pi cancel bhi kiya, so 1 plus n is equal to 2, right? And n will not be equal to integer, right? So then this is wrong. It cannot be possible. Half plus n equal to 2 only if n is 3 by 2, but time has to be integer. Discrete time domain mein time has to be integer, right? Okay, so this n equal to 1 is not the correct period. Okay, I can still assume that the signal is periodic. Maybe let me try with the next option, that is period 2. Okay, let me try with the next option. So let me call this actually as option number A. Okay, now let me try it with the option number B, n equal to 2. So I have to check x of n plus 2. That will be equal to sine of pi by 2 n plus 2 whole square, open the bracket, sine of pi by 2, directly open kar dete hain. First is n square, next will be 2 square, that is 4. So for pi by 2 into 4, that will become 2 pi. Next will be 4n, so again 2 will cancel, so that will be 2 pi n, right? Okay. Now dear, this is equal to sine of pi by 2 n square plus 2 pi common liya, so 1 plus n. Acha, in dt domain, in the dt domain, n is always an integer. Right? N is equal to integer. Correct? Right? N is equal to integer. So 1 plus n. N is equal to integer. So 1 plus n, right, into 2 pi is equal to integral multiple of 2 pi. And dear, at every integral multiple of 2 pi, right, sin theta will repeat. Sin theta plus 2 pi k is sin theta. बोल सकते हैं ना, sin theta plus 2 pi, sin theta plus 4 pi, sin theta plus 6 pi. It will all be equal to sin theta. Okay, so this is equal to sin theta. Sir, what is the theta? Pi by 2 n square. It is equal to sin pi by 2 n square. It is equal to xn. This is equal to xn. Very clearly, yes, Fahad, the answer is yes. Very clearly, I have proved that x of n plus 2 is equal to xn, right? So the given signal is periodic, having the time period equal to 2. Acha, why I started checking with the smaller option? ये वाला तो aperiodic था, but still, why I started checking with the smaller option? Why I didn't start with 4? I have done 1 to 4. I could have gone 4 to 1, but why not like that? The simple reason is, if 2 is the period, if signal repeats after 2, it will automatically repeat after 4. If it repeats after 2, it repeats after 4 also. But will the time period be 4 or 2? The time period has to be the lowest value of time. Na? That is why you have to start with the lowest. Okay, if you start with 4, that also becomes the answer, but that is not a fundamental period and you will not get the marks for it. Okay? So start with the lowest here. That is the actual logic. Acha ji, ye to ho gaya dt. Okay, then I told you sin t square. This is aperiodic. But suppose if I have a question, same question, pi by 2 t square. Will this be periodic? Continuous time domain. Will this be periodic? So dear, I have just one point to tell you here. X of t plus 2 will be equal to sine of pi by 2 t plus 2 ka whole square, and that is equal to sine of pi by 2 t square plus, again you will get the same result, 2 pi 1 plus t. Right, this will be pi by 2 into 4, that is 2 pi, pi by 2 into 4t, that will be 2 pi t. So 2 pi common into 1 plus t. Now tell me, in the continuous time domain, is it periodic or not? In the continuous time domain, is it periodic or not? In the continuous time domain, is it periodic or not? Dekho dear, here t is continuous in nature. So 1 plus t, last time kya tha? N is always an integer in the discrete time domain. So 1 plus n into 2 pi. If n is an integer, 1 plus n is an integer. So 1 plus n into 2 pi is an integral multiple of 2 pi. But here 1 plus t into 2 pi cannot become an integral multiple of 2 pi always. Okay. Right. Say for example, t can be anything. T can be 0.1. So 1 plus t into 2 pi kitna ho gaya? 1.1 into 2 pi, that is 2.2. And sine theta doesn't repeat after 2.2 pi. It repeats after 2 pi, 4 pi or etc. Okay. So because it is not equal to 2 pi k, x of t plus 2 will not come back equal to xt. Will not come back equal to xt. Okay. So this particular signal in the continuous time domain will be aperiodic. In the continuous time domain, that is going to be what? That is going to be aperiodic. In the continuous time domain, it is going to be aperiodic. Chalo. Now one MSQ question based on our yesterday's discussion. Okay. Yesterday we solved the question. Same question in the CT domain. Same question, only thing is replace the n by t. Right. Yesterday we solved this question in CT domain and my answers were A, B, C, D. My answers were A, B, C, D. My answers were A, B, C, D. In the continuous time domain, all 4 options were correct. Okay. If xt is periodic, y1t will be periodic. If xt is periodic, y2t is also periodic. If y1t is periodic, xt is periodic. If y2t is periodic, xt is periodic. What is y1 and y2? The compressed and the expanded form of a signal. In the CT, all 4 options were correct. I have explained you yesterday. You can refer to that. But in DT domain, whether still all 4 are correct? आप एक चीज ध्यान रखना that in the DT domain, I have explained you in the very beginning classes only, dear. What is the y1n? What is the y1n? Y1n is x2n. X2n represents compression. And dear, in the DT domain, there is a problem. When you compress a signal, because of that limitation of integral time, when you compress a signal, there is a loss of data. 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 But y2n is x of n by 2 and that is known as expansion. And what happens when you expand the signal? In the case of expansion, you see zero padding. How this was officially defined? Matlab, this was officially also written as, yes, it will be equal to x of n by 2 for all even values of n. Because even divided by 2 will be an integer. Inside any discrete time signal, the argument should be integer. But if n is odd, it's going to be 0. It's going to be 0, right? Okay. So zero padding. We have seen the waveforms also. Okay. What we get after expansion is the zero padding, but what we get after the compression is the loss of data, the loss of samples. Okay. I think I've explained you in the very first or the second class of this particular fundamental series. Okay. The first class itself. You can go through it. That is why always follow the lectures in continuity. So because there is a change in the data, it is not like continuous where only signal will compress or expand. In continuous, it is only compression, the time period also compresses. The signal expands, time period expands, but there is no effect on periodicity. That is what I explained to you yesterday. But here, there is a change in the data, extra zeros coming up, or there is some loss of the samples. And that is why let us understand this question graphically. And let us say that this is equal to 3. Okay, this is a periodic signal with the period equal to 3. Okay, now what happens if I expand it? Dekho, right now the signal is 211, 211, 211, etc. If I expand this, matlab x of n by 2. If I expand this, expand mein maine kya bola? Zero padding will come. Okay, the signal will look like, starting from origin only, the signal will be 2, 0, 1, 0, 1, 0. But eventually 2 aayega na. 2, 0, 1, 0, 1, 0. Zero padding is done. Then there is 2, 0, 1, 0, 1, 0. And etc. Right. So there is this repetition. Right. This is periodic. Right. This is periodic. Only thing is, period will also double. Initially it was 3, now it becomes 6, right? With the period 2n. It is periodic with period 2n. On the other hand, if I talk about x2n, that is known as compression. That is known as compression. So if you compress, there is a loss of samples. Okay, only the samples which are at even, because you are dividing by, you are taking 2n, only the samples which are at even time, they will be saved. देखो ना, आपको क्या करना है? Compress करना है. ठीक है, try to compress now. Compress means you divide the value by 2, right? So 0 by 2, origin as it is रहेगा. Let me start by origin 2. But this sample, which is at time 1, will go to the time half. But half time is not acceptable. In discrete time, half time is not acceptable. So this sample will be lost. It will not come in the compressed form. Then let us come to this part. Okay, this is at 2. 2 divided by 2 will be 1. So it will come at the time equal to 1 and the value is 1. The next sample is directly 1. Then dear, even this is lost. Even this is lost. Because 3 divided by 2. Compress means you have to divide time by 2. So 3 by 2, that is a non-integer time, not acceptable. So this signal is lost. Okay, then next time is 4. 4 by 2 is an integer. So next sample will come. Okay, then 5 by 2 will not come. Forget. Then 6 by 2 to aayega. 6 by 2 to aayega, 6 by 2, 3. So again you will get a 2 here. But dear, once you get this 2, after that to repeat hi hoga na. Once you get back this 2, after that it is repetition. This 1 will come, ye nahi aayega, next wala 1 aayega, and so on and so forth. So eventually it is going to repeat. Okay, once you get back 2, you again get 1, 1, then again you get 2 and 1, 1 and etc. That means it is still periodic. It is still periodic. But only thing is, eventually we should not comment on the final period. It may be same, it may be altered also. But this is periodic. Okay. So here, dear, पहले options पे आते हैं. If xn is periodic, y1n, the compressed form is periodic. If xn is periodic, y2n, that is the expanded form, that is periodic. An, sorry, this is a typo error with the options. मतलब arrangement differ हो गया है. Slight difference in arrangement. I'll make that correct. So at least I am telling you that A and C are correct. Now let us talk about B and D. Sir, very clearly you see, right? B, if y1n, what is y1n? Y1n is the compressed form. If that is periodic, will the signal be periodic xn? Assume, इसी के respect में समझेंगे. Assume this is y1n. Assume this is the compressed form of a signal. Assume that this is a compressed form of a signal, very concentration, full concentration, important point. Assume that this is the compressed form of a signal. Graph से समझा रहा हूं, calculation बहुत lengthy होगा. And this is periodic. Clear now, I have taken a periodic waveform. But if this is a compressed form, I know that whenever I derive any compressed form, there was a loss of data. Okay, so when I retrieve the original signal, this is compressed form of something. Data has been lost. But if you try to dig the original data, okay, maybe here the value was 3, that was lost, na? and maybe here the value was equal to something else, maybe here the value was something, here the value is something. It can be aperiodic, na? Try to understand. I am assuming that this is y1n, that is the compressed form. Compressed form is obtained after loss of data, after every alternate data was lost. So suppose if I retrieve the original signal, maybe here this was, suppose 3, this was -1, this was 4, this was 1. So no way, okay, there will be periodicity 2, 3, 1, -1, 1, 4 aa gaya, then suddenly 2. There is no pattern of repetition. Any values are coming at random. So that means if the compressed form is periodic, signal is periodic, not guaranteed. Not guaranteed. ठीक है? But option D पे आते हैं. Y2n is periodic. Y2 means expanded form. Expanded form is obtained after zero padding. Okay. So original signal. इसके लिए मेरे को एक और एग्जांपल लेना पड़ेगा. Right. This is the expanded form and this is periodic. Okay. Suppose this is 1, this is 0. Expanded form always contains zero padding. ठीक है. This may be 2, then this is 0, then this is 1, then this is 0, this is 2. ये repetition हो गया ना, 1 0 2 0 1 0 2 0. When you come to the original signal, this is expanded. Expansion is obtained after zero padding. Remove those zeros. Remove these zeros, remove these zeros, remove these zeros. So now you have the pattern. Earlier it was 1 0 2 0. Now you have the pattern 1 2 and again 1 2. Still periodic, na? Only zeros are repeated, but rest values are same, na? Okay, so you have 1 0 2 0 1 0 2 0, but original signal may contain 1 2 1 2 and it is periodic. And that is said to be periodic. And that is why, dear, D option will be correct. Only and only B option will not be correct. If you want, I can write down some comments here. B option क्या बोलता है? Y1n, which is x of 2n, is periodic. Okay, the compressed form is periodic. The compressed form of a signal is periodic. मैंने ग्राफ से explain तो किया, but I'm writing down some fundamental point. Compressed form is obtained after loss of data. Okay, so after some samples were lost, then the signal is periodic. Original signal. Okay. May or may not be periodic. ग्राफ से भी समझाया मैंने आपको, ग्राफ से भी समझा दिया. May or may not be periodic. ठीक है. So B is the only incorrect answer. Rest, the answer for this multiple select question is A, C, D. The answer for this multiple select question is A, C, D. Is A, C, D. Right. Okay, dear. So, what is going to be the password for today? आज का password रख लेते हैं sample. Okay, so I'll share you the PDF in Telegram. PDF will be password protected. Simple password randomly framed is sample. All small. Sample. SAMPLE. Okay. Also, guys, that for all those who have qualified the ESC prelims, the BYJU'S Exam Prep brings you the ESC mains complete practice course to boost your performance. In the ESC mains examination, and this will contain live conventional practice classes, the comprehension practice test. Okay, so the conventional practice test, and that will be also evaluated by the expert faculty, live doubt sessions, right? And this batch starts from 3rd of April. Just go to the BYJU'S Exam Prep app and you can enroll for this ESC Mains 2023 course. It is available for electronics, electrical, civil, as well as mechanical. And also, guys, for computer science as well as for EC students. Okay, NILET has brought up huge vacancies, around 598, and that is why to make yourself, to conquer your dream of becoming an IC scientist, you can enroll to the Target NILIT course. Yes, yet another course offering you 240 plus hours of live classes, 15 plus chapter wise notes, 100,000 plus practice questions, and this course goes live from 1st April. Okay. Also, guys, as I've been telling you, 2nd April, Learn with Fun is going to start. This is the first season. This is the first episode. Me and Ashu Jangra sir combinedly have done an experiment and tried to explain you what skin effect is. This is coming on the Sunday, 2nd of April. And then every Sunday you will have videos to make your learning enjoyable, to make your learning with fun. Okay, and the BYJU'S Exam Prep users, students have been following us, and they have, they've really proved themselves in the GATE 2023 examination. The success saga continues. 13 ranks in single digit, that is they are under 10, 107 ranks under 100, and 62 ranks under 50. Phenomenal records. And that's it for the class, guys. Now I will see you tomorrow once again with the very important concept, energy and power signals. Very important concept of energy and power signals coming up tomorrow, same time 9 p.m. Stay tuned to BYJU'S Exam Prep YouTube channel, and do not forget to subscribe the channel to get the regular updates about all the events happening on the channel.